we are going to practice doing some simple calculations involving measured numbers and correctly reporting the answer with an appropriate number of sig figs. The sig fig rules we're going to use are printed at the top of this page. They are also in your notes. Most importantly, when you do these problems, you want to remember to write the calculator answer down and then go back and worry about sig figs. To speed things up, I'm going to go through and write down the calculator answer for all of these problems. The first set of problems are all addition-subtraction. Now in addition-subtraction, we need to be focused on decimal places. Now if we look at this first problem, we see our first uncertain decimal place is the third decimal place, which corresponds to the thousandths place. And the second number is good to the hundredths place. So our final answer is only good to the hundredths place because this is the first uncertain decimal place. So we need to stop after the hundredths place. We look at the first number to be dropped. It's less than 5, so we round down, which means we simply drop that number and all of the rest of the numbers to the left. Our final answer is 457.12. The next problem over, we have our first uncertain decimal place in this number is a thousandths, or we can say 3 decimal places. And our second number is only good to the tenths, or 1 decimal place. So we report our answer with the same number of decimal places as our worst measurement. This answer here, the second answer, the one with the least number of decimal places, is going to be the worst measurements. So we have to stop after the tenths place. The first number to be dropped is less than 5, so we drop everything to the left. Our final answer is 94.7. Now the most common mistake in sig figs is forgetting whether you're multiplication and division or if you're doing addition subtraction. All of these initial problems are addition subtraction, so we focus on decimal places. In this next problem, we go all the way out to 5 decimal places. However, our worst measurement is this second number here because we only have 3 decimal places. So our worst measurement always determines the sig figs. In this case, it's 3 decimal places, which means that our final answer is correctly expressed as 0.110. The next one over, we have 2 decimal places. In this first number, the second number doesn't have any, so it has 0. Or we can say it's the ones place. So we know we can't go beyond the ones place. Our final answer here is obtained by rounding down and is 97. The next problem, we have 2 decimal places in both numbers. So our answer should have 2 decimal places. So what we're going to have to do is to add 2 zeros after the decimal place, after the decimal point. We can't report our answer as 1 because that's not precise enough. Our final answer is 1.00, indicating that we know that the value of this decimal place is 0, and this is most likely 0. In this final problem, we have 3 decimal places here and 2 decimal places in the second number. The second number here is going to be the worst measurement, so we can't go beyond 2 decimal places. Here, the first number to be dropped is greater than 5, so we round up. Our final correct answer is 2.01. Now these problems all seem very easy, and they are, provided you remember that you're doing addition subtraction and therefore should be focused on decimal places. The next set of questions are multiplication and division, in which case you count the number of sig figs. The number that has the least number of sig figs is going to be your worst measurement, and that's how many sig figs you can justify in your answer. In each case here, we see we have 4 sig figs in the numerator and 4 sig figs in the denominator. Now remember, all the numbers 1 to 9 are going to count as significant, so the only question we have is this captive 0, whether or not it's significant. We know it's significant because it is captive. We know this value is 0, so it counts. We have 1, 2, 3, 4 sig figs in the bottom, 4 sig figs in the top, so we want 4 sig figs in our final answer. 1, 2, 3, 4. So we have to stop after the 1. The first number we drop is less than 5, so we drop all of those numbers, and our correctly reported answer is 765.1. In the next problem over, again, we're counting sig figs for each of these numbers because this is all multiplication and division. So we have 2 sig figs here. This leading 0 does not count, so we know that we have 3 sig figs in 0.465. This number here has 4 sig figs. They're all digits 1 to 9. And this number has 3 sig figs. So the least number of sig figs we have out of all these numbers is 2. So we report our answer with 2 sig figs. Note that I've rounded down because the first number after the drop digit is less than 5. Okay, the next one, we have multiplication division, a number with 3 sig figs. This number has 4. This has 2. Okay, this one's easy because all of the digits are 1 to 9, so we know they all count as significant. The least number of sig figs is 2, so we want to count 2 sig figs. Now remember, this leading 0 does not count as a sig fig, so we count 1, 2. We stop after 2 sig figs. The first number we drop is greater than 5, so we round up. Our final answer, 0.87. Okay, 1.66 cubed. And as a quick reminder, that means 1.66 times 1.66 times 1.66, and we have our calculator answer. The 1.66 has 3 sig figs. Therefore, our final answer should have 3 sig figs. 1, 2, 3. We stop after the 7, and we're going to be rounding down because the first number that we drop is less than 5. Our final answer is 4.57. For these more complicated problems, again, write down your calculator answer first, then go back and worry about the sig figs. Let's look at the numerator here. We have a number, it's a multiplication. We have a number with 4 sig figs. Remember, this initial 0 does not count as significant. It's a leading 0. This number has 3 sig figs. So in this top part, just looking at the numerator, we know this answer is correctly expressed in 3 sig figs. Now let's look at the denominator. The answer to this problem, 490.1 minus 488, is equal to 2.1. However, we need to consider how many sig figs are justified in this result. In this result, we see that there's one decimal place here, or it's the tenths, whichever method you prefer, and here there's 0 decimal places, or we can say this is the ones place. So in this answer, if we were to report this as an individual answer, we can only use 1 sig fig because we can only go out to the ones place. We are not going to round off this number. That's why we made sure that we wrote the calculator answer. We're going to use the entire number. We're not going to drop any sig figs. We're not going to do any rounding until the end. However, when we get to the end, we recognize that this result can only support 1 sig fig. So we have our 1 sig fig. Now our final answer is reported using just 1 sig fig. It's 8. Again, write down your calculator answer first, then go back and figure out your sig figs. If you try to figure out your sig figs on the way to getting your answer, you're going to likely introduce rounding error, and you don't want to do that. So do the entire calculation, write out your sig figs, or write out your calculator answer, then worry about your sig figs. Okay, if we look at this last problem, the second number has 4 sig figs, because we know these first 2 zeros do not count as significant. This number with 4 sig figs is multiplied by this result. So we need to determine how many sig figs are correctly justified in this result. So if we do this addition, we get a calculator answer of just this addition part of 7.2371. Now we look at our decimal places. Here, in this first number, we have 4 decimal places. This number, we only have 2 decimal places. The result can justify 2 decimal places, and 2 decimal places for this number is going to result in 3 sig figs. So we have a number here with 4 sig figs multiplied by a number with 3 sig figs. So our answer is correctly expressed with 3 sig figs. So the 0 doesn't count. We count 1, 2, 3. This first number to be dropped is less than 5, so we just drop all of those numbers, and our final answer is 0.122.